Hi, in this video, I will show you how to perform principal component analysis and linear discriminant analysis using Minitab and IBM SPSS version 20. Right, so in this example, we are going to use my PhD students' data um, in the Excel form here. So as you can see, these are the different data that we have. Right, so if you look at the lower tab, you can see less rainy, rainy, and east. Okay, but I just want to give some idea what the data are all about. The data are actually coming from her analysis of several trace elements. Okay, using ICP OES. Okay, on stingless bee honey samples that she collected from the different regions as well as district in Peninsular Malaysia. So she collected samples from East, North, Central, and South regions. And for each region, there are four districts that she included. For example, in East, she has Jerantot, Rompin, Temerloh, Kuantan. For the north, she has Parit Bunta, Kuala Muda, Yan, and Bagan Serai. For the central region, she has Sabak Bernam, Kuala Lumpur, Kuala Selangor, and Hulu Selangor. While for the south region, she has Segamat, Johor Bahru, Pontian, and Mersing. And then she analyzed the sample for zinc, nickel, chromium, cadmium, and so on. Okay, and these are the concentrations that she got from the ICP-OES analysis. She performed this analysis using specimen or samples of stingless bee honey collected during less rainy as well as rainy season. So one of the objectives is actually to see whether it is possible for her to we call identify the location or the region from which the stingless bee honey samples were collected using the pattern recognition technique based on the concentration of the different elements that she analyzed using ICP-OES. Okay, for the purpose of this demonstration, I'm going to show you how the analysis can be done using IBM SPSS as well as Minitab. And we are going to focus only on one of the sets of the data, which is the rainy season, the data that she got during the rainy season. Okay, so basically what you should do now is you can select all. Okay, you can select all the data, copy, and then you can go to your Minitab, right? So here you can click and paste cell, right? So you have your data already in the Minitab environment. So you have region, zinc, etc., etc. Okay, so make sure that you get everything. Okay, so now we are good. Now to do this, for the first thing that we are going to do is to do the principal component analysis. Okay, look carefully on the analysis. So you can click statistics, go to multivariate, principal component. Okay, then select all the elements. Okay, and transfer the element, select the element to the variables. Okay, number of components to compute, usually I choose 10 number of principal components. You can choose 6, 7, whatever you want, but I usually put 10. Okay, then you can click OK. Look carefully, there'll be a box indicating something. Right, so after we click that OK, this box is prompted. You can see that error. Ti, titanium, is nearly zero or nearly constant, meaning that the data that she has for titanium, the values are all zero. So the computer is asking, are you going to compute this? Because the data are actually zero. I mean, the value, the concentrations are actually zero. So we are going to omit this titanium, okay? Because the values are zero. Cancel. So we click C13 where the titanium data are located. Click, right click, and then you can delete cells. Okay, now do again the analysis. You can add multivariate principal components. Okay, then in this time I want to make sure that okay we click scree plot. Okay, okay, then you click OK. Right. So this is the scree plot showing the variance. Okay. So you can see that the shoulder is somewhere here. Number principal component 1, 2, 3, 4, 5. Even 6 you can still use. Okay. 1, 2, 3, 4, 5, 6 here. Okay. And before it becomes plateaued here. Right. So principal component 1 is actually contributing to the largest contribution of the variance is coming from principal component 1 followed by principal component 2, 3, 4, 5, and 6. Okay, now we are going to compute the principal component values. Okay, so I'm going to put the values here in the same window, C15, 16, 17, 18, 19, 20. So the 6 principal component. So you can go to stat again. Okay, now you go to multivariate principal component. Now you go to storage. Okay, in storage, in the score box, you place the C15 to C20, right? So click OK, right? And then OK. So these are the principal component values computed by Minitab. So you can label this as PC1, PC2, PC3, PC4, PC5, and principal component 6. Okay, right? So before we go further, I just want to show you that principal component 1 is actually, if you look carefully, here the values, principal component 1, 2, and 3, and 4. Okay, the cumulative value of the variance is actually, for PC1 is 48.3%, cumulative of PC1, PC2 is 62.3, and then cumulative of PC1, PC2, PC3 is 70.7%. So 70% is actually the cutoff value. So this is acceptable because 70% of the minimum of 70% of the variance are actually attributable to PC1, 2, and 3. So the model is actually acceptable. Okay. Now you go to graph. Okay. Select 3D scatter plot. Select the simple the plot. Okay. Now the variables. Okay, so x variable will be PC1, y variable will be PC2, z variable will be PC3. Okay, then you can click OK. Now this is the scatter plot. Okay, we enlarge this window. Right, place your cursor on the dot, any dot, right click, and then you go to edit symbol. Go to groups. All right, we want it to be grouped according to region and district. So select and place that in the categorical variable grouping. Then you can click OK. So now you have the region. Okay, you can rotate the 3D scatter plot using this 3D graph tool. Okay. Okay, so the different colors, the different color of the triangle will dictate the different location where the stingless bee honey specimens are collected. So as I explained in my class, the PCA is actually a non-supervised method. So it allows the data to fall naturally without putting any specific parameter or any specific what we call teacher factor to be classified. Okay, so you can see that the PCA, okay, this is the organization of the data. But at this stage, you can't really see, you can't really do prediction because PCA does not allow that. It only allows you to see the organization of the data, right? So this is the first part, the principal component analysis.